So let's recap on all the rules, and then I want you to, we're going to then copy down the last rule for today. Next year you want one extra rule on top of that. But I don't want to overload you, so we're just going to do what you need to do for year 11. Okay? So here we go. When you have a power function, how do you find the derivative of a power function again? Can I please have, Rachel, what was the rule? If it was ax to the power of n, what's the derivative equal to? Correct. A times n or n times a doesn't matter. 2 times x to the power of n minus 1. Good. That's the derivative if you have a power function. What is the derivative of e to the x? Will? It is e to the x. It is itself. It is itself. Okay. There we go. So dy dx is e to the x. Okay. What about the derivative of log e of x, Akita? Ben? 1 over x. Okay, so derivative of log e of x is 1 on x. Okay, so all of these I'm giving you the most basic function, the only thing we know. So if it's e to the x, only the variable of x, then it's e to the x. If it's log e of x, then it's 1 over x. Okay, next one. Sine of x, derivative sine of x. Let's go with Seb.
Cos of x.
Cos of x, good, but then don't confuse this, because this is where commonly next year they will do this on purpose. What is the difference between cos and sine? Derivative of cos, what is that, Hamish?
Sine x.
It is sine x, but one thing that we... Negative. Okay, this is what's going to happen next year, especially when you learn integration. It's easy to mix the two. Okay, so sine will become positive cos, cos becomes a negative sine. And that's commonly used for next year. So when you do see it next year, just really try to remember that one. Okay? Now, I am missing one. So we've got power function, we have exponential, we have log, sine, cos, and tan. And what was the derivative of tan again? Can I please have Oscar?
1 over cos x squared.
Good. 1 over cos of x all squared. Okay? Alternatively, you can write the second squared of x. Means the same thing. Okay? So, second means 1 over cos, but when you're squaring the sec of x, then it is 1 over cos of x all squared. Okay, that's what the derivative of tan of x is. So these are all your 1, 2, 3, 4, 5, 6 rules, and there was one last one that I said was your bread and butter of calculus, starting with C. What's the bread and butter? What's one more rule that I have not mentioned about, but I wanted you guys to learn this? It was very important. Chain rule. Okay, what was the chain rule again? Can I please have Matt? Good, that is true. That's how you use chain rule, but what was the rule again? dy dx equals to? Oh, so close. It is. dy dx equals to d something times something. Akita. Very good. Okay, so this is your chain rule. I'm going to just rub all of this off. And just going to rewrite it again. So when you have tan of x, then the derivative is equal to the sec squared of x, or 1 over cos of x all squared. Okay? Chain rule. Like Matt said, when you use chain rules, you introduce a third variable, which we call u. It could be any letter you want. But once you introduce a new variable to make the problem easier, then you find the derivative, dy du, and then du dx, multiply those two together, see du's cancel out, and you end up with dy dx. Okay, that's the purpose of chain rule. And you can use chain rule in every one of these functions. And that's what next year's all about. Okay? So if you remember one of the exam papers I showed what my class was doing at the time, they were actually doing chain rule with all those problems there. Okay, it's the part of the first question. So I promise you next year, your first question of exam 1 2019, I don't even need to see it. I can promise you the first 4 marks out of 40 is going to be a chain rule of some sort. Okay, so they might mix it up and whatnot, but it is going to be a chain rule and it's guaranteed. It's been the same for the last decade or so. Okay, so it hasn't changed, it's just what you see. All right, so chain rule, bread and butter, learn it. Okay, now, last rule for year 11. I've taught you chain rule, I've taught you power rule, and I've taught you the rule for exponential log, sine, cos, and tan. The one last rule you need to know today is called the product rule. Okay? I'm going to show you the product rule, and I'm going to get you to memorize this the way I teach you. Okay? Because I don't want you to mix it up when you learn it for next year. There's going to be a different way on how they teach it to you. You learn it my way, and you'll remember the quotient rule. Because right now I'm only teaching you product. When you learn the quotient rule, it does matter which one comes first. Product rule, it doesn't, and in your textbooks it's a bit different, okay? So this is how I want you to memorize it. Now, what is product? Product back in year 7 means times, okay? So when you have two functions that are multiplying to each other, so the examples I gave over here, is you can have a linear function, x minus 2, times product with 2x plus 3. That's product problem. If you have 2x, which is again a linear function, multiplied to sine of x, that's a product. You can use product rule first. What's another example of a product rule? You could have x squared, that's a quadratic problem. So a quadratic function multiplied to an exponential function. This is when you can use product rule. How is this different to chain rule? See, chain rule was to simplify it, so it's something you know. Now you can't simplify this. See, because if I change x, then I can't change that. If I change the 2x, then it doesn't change this x. I can't replace it with another letter. Whereas, example, what is a chain rule problem? I could say sine of 2x. See, that one I can replace. I can replace the 2x with a new letter. If I gave you e to the power of x cubed plus 1, see, I can replace that. And it's just e to the u. But I can't replace it if I gave you x cubed plus 1 multiplied to e to the x. So what do I replace? Because if I replace this with a u, then what about that x? That's a problem. Whereas before I could. See, this one I could replace with a u. This one I could replace with a u. This one I can't. Okay, it always goes back to the 6 rules I gave you. You want those. That's the problem. So this is a product rule problem. That's a chain rule. And so next year, your first question is just to see if you know the difference between the two. That's why it's easy to do. And you know it's there, so learn it. Yeah? Now, so how do you do, if you do know it's a product rule, how do you use the product rule? Here we go. The product rule says if you know you've got first function, we call u, and the second function is another one, we call it v, right? So u times v, then the derivative, which I want you to copy down now, is this. This is the rule, and I want you to copy it exactly the same order as I've written. Okay, so vu dash plus uv dash. Okay, what's the dash? It means the derivative. Okay, so this means whatever the function for v is, multiplied to the derivative u, add with u times the derivative of v. That's what it means, right? Why I want you to memorize it this way, because when you do your quotient rule, when you're adding, it doesn't matter which one you add. 2 plus 1 or 1 plus 2 doesn't matter. But when you do quotient, the rule is going to be a subtraction. And subtraction does matter. It does matter if you do 2 take away 1 or 1 take away 2. So I don't want you to confuse between product and quotient next year. Best way I want you to learn it is like this. But in your textbook, when you learn it for next year, product rule, they will write it the other way around. Because it comes with uv, and they will write uv dash plus vu dash. And it's likely you'll stick to that rule, and if you look at your formula sheets, it will be the other way around as well. And it's easy for you to confuse with quotient rule. That's why quotient rule in the last 3-4 years has been coming up. Okay, because students keep getting that wrong. So to make sure that you don't get it wrong, I want you to do it this way. And how I remind my students, you can ask my year 12s, I keep saying it throughout the year, it's Victoria University first. That's the RN. Okay, so we're going to say Victoria University first, VU first. Okay, so VU comes first, and we're always thinking about that. Victoria University first, VU dash, and with UB, not UBS. Okay, so Victoria University first before you do UB. Right, now, how do we do this? All you needed to know is once you know it is two functions multiplied to each other, the derivative is v times the derivative u plus u times the derivative v. Let's do an example. Okay, so I just wanted you to copy the rule. We're going to do an example, and then I'm going to give you this worksheet here. It's broken up into 3 levels. First one is straightforward, apply the rule. As you move down to the mastering and fully factorizing, you're going to be doing chain rule and product rule together. So remember I said chain rule can fit into anything. Chain rule can work into product rule. That's where it gets tricky. That's when you mastered it. Okay, so get the last part, the answers on the left. This is what you want, because next year, that's likely the problem that you're going to get. And the mastering part is the likely questions. The top one is your textbook questions. Okay, and you're not going to get textbooks in exams, right? So, copy down the rule, we're going to do an example, and then I want you to practice this, and we're going to give you 15 before you look at the answers. Okay, so let's go. Here we go, let's do an example of a product problem. Let's take this one. So the rule's on the side there. If you didn't copy it before, it's on the top right corner. Here we go. Oh, I gave you an exam question. Okay, so this is a VCO exam question. I think it would have been prior to 2016. Looks like a 2011 one. X times log U of X. So this would have been the first question of either the VCO 2011, I reckon. And how do you know it's product? Again, you've got a linear function, x multiplied to log U of x. They're two different functions, okay? And they're multiplied to each other. Now, it could be a linear with a linear, but regardless, these are multiplied to each other. It's not a function within a function. Then you would have used chain rule. Now you're using product. So in this case here, I'm going to call x, okay, I'm going to call x, I'm going to call x u. And I'm going to call v, the second function, log U of x. Okay, because I know it's u times v. And according to the rule, we said it's v times the derivative u plus u times the derivative v. You see what I'm doing there? So I got u times v.
Tell me your voice password to continue.
Must be something I say. Sometimes it sounds like Bixby, but it's not. Okay? Is that rubbish? Yeah, no, happens all the time. I'm in a meeting with Mr. K and he said something. I can't remember what it was, and that thing just keeps repeating. Sorry, can you say that again? Can you please repeat yourself? You know, I'm like, no. Go away. All right, now, let's answer this question. We are going to find, so here we go, I'm going to split it up. We're going to call u x, and we're going to call v log U of x. Now, derivative of x. What is the derivative of x? 1. 1. Good. Using power rule, we know derivative of x is equal to 1. Now, if I called v log U of x, using your rules that I've given you so far, the derivative log U of x is 1 over 1 over x. Okay. So, we've got v dash, we've got u dash. Now, according to the rule, it's v times u dash, so v times u dash, plus u times v dash. Okay, so really you're doing a crisscross there. So if I do a crisscross, you actually go v multiplied to u, so you got log e times 1, so v times u dash, plus u times v dash, so u, which is x, multiplied to 1 on x. Okay, so wait, let me just remove this part there. So this is plus u v dash. Okay? So if you simplify that, if you think about this is v times u dash plus u times v dash. Now x times 1 on x, we know it cancels out the x's. We know that log e of x times 1 is itself. So now the answer has to give you log e of x plus 1. This is the derivative of the above. Now if you found that easy, that's 2 marks. Okay, simple and easy. 2 marks out of 40 for next year. Okay, and that's why I'm saying since 2011 they've increased the difficulty because kids are getting better at it. Okay, it used to be chain rule. Kids sucked at it. Then they had that for 2 years. Kids got better, so they went to product. Kids got better at product, we went to quotient. So now we're sitting in between quotient mixed with chain. That's where we're all sitting at. So all my year 12s right now, I'm telling them, learn your quotient, product, and chain, and it's likely going to be a mix of the two. It's going to be a product with a chain or a quotient with a chain. It's likely quotient because students hate fractions and negative. So it's going to be something like this. I can promise you next year it's going to be something similar. If this year they do bad with a quotient, then you're likely going to get a quotient for next year. Okay, it's going to be something like this. It could be e to the sine of x divided by, let's say, I don't know, let's do a cos of 2x squared. Something like that. So that's a chain rule with a quotient problem. Okay, but you haven't learned quotient rule yet, but that would be a typical problem for next year. Okay, prior to all that, it used to just be like what you see here. It used to be just root of 2x minus 1, something like that. So you had to do that, or you would have had something like x times sine of 2x. Those were your typical problems, but as you guys got better over time, They don't use that anymore. These are your textbook questions now. Okay? Yeah.
Did you do chain rule or quotient rule for that?
You will have to do quotient, but within the quotient, you have to do chain. So it's kind of like, see this one, this is v,
Yeah.
so that's log of x. It just so happens that the derivative was just 1 on x. But if I changed the x and I made it, I don't know, let's say x squared plus 1, then you have to do a chain rule here to find out the derivative. See what I mean? So you're still using
So
quotient.
you use the chain rule to find out all of those 4 values and then you sum them in?
Yeah.
Okay.
Okay. Now, let's do another example, okay?
Wait,
Yep.
there'd be situations where
Yeah.
you could do chain rule and then you have to do products of classes.
Yes, there could be. Yes, there could be. So you could have, let's say, a chain rule where you would do a product. It would have to be something. I haven't seen that problem before, but you could have that. You could have log e of, let's say, sine of x times cos of x. See that one? You use chain rule first because you're replacing that with a u. We call this u, but then within u, to find the derivative of u, dy du, this is a product rule. So chain then product.
Hopefully you don't get that.
Yeah, that I don't normally see. Normally you see it the other way around. Normally you see it like this. You normally see sine of x times cos of log e of 2x. Something like that. So that's a product rule. This is a product of sine times cos, but within the cos you've got log to remove. So this is a product using chain, whereas the one above was a chain problem, but a product within the chain. Okay, that one I haven't seen. This one you normally see. Yeah. All right, good. But at least if you can think of if you can ask me those questions, that means you understand the difference. That's important. Okay, so that you know the difference between the two. All right. Now, let's do one more example. Let's take. This is on your sheet. I'm going to give you the sheet later, but this is the standard textbook questions on how to do product rule, right? So you got your rules. Let's do number 2 first. Okay, let's do number 2. So y equals to x cubed multiplied to cos of x. Okay, so if we're looking at this, how do we know it's product or chain? Clearly, it's not cos of something that you can replace. There are 2 separate functions that are multiplied to each other. Product rule straight away. So what's product rule? You need to know which one's your u and which one's your v. Okay, in this case, what is my u and what's my v? What's my u and v? Good. And v? Very good. So all you need now, once you define what u is, and what v is, then now you just got to find the derivative. So here we go. I'm going to do it in green. What is u dash, which is the derivative? Derivative of x cubed. What is that? X squared. 3x squared. Good. Next one. V dash. Good. Don't forget the negative. Negative sine of x. So now using your product rule, which I'll do in another color, say purple, dy dx is equal to, remember it was, v u dash plus u v dash. So we go, our v was cos of x, multiplied to 3x squared, plus u, which is x cubed, multiplied to negative sine of x. Okay? Answering our question. Now, for you, this is I'll show you the year 11 answer and then the year 12 standard answer. Okay, so here we go. In year 11, you can rewrite it as 3x squared cos of x plus, oh, not plus. Well, what? Let me do it again. See, you got the minus in front of the sign. When you multiply it with x, it becomes a minus x cubed sine of x. Now, if you did this in year 11, you're not going to get penalized. And this is your derivative, right? In year 12, this is not a proper answer. This is an unsimplified answer. So when I give you the worksheet, you'll see this is no factorizing. You're meant to factorize in year 12 because wherever you can simplify, factorizing is simplifying, you're meant to. So here, you're meant to look at the common factors between 3x squared cos x and x cubed sine x. What's common about the two? X squared. Good. They both have a factor of x squared. Don't mean to take that out. So year 12 answer. Year 12 answer should be x squared bracket 3 cos of x minus x times sine of x. This is a better answer for year 12 for a 2 marker. Okay, so that could have been your first question. And it used to be. That used to be the typical first question for an exam 1 of next year, the VCE methods. That would have been a typical question. Okay, and then that's exactly how you would have to write it. Would have been 2 marks. Now, that would be worth 1 mark if they did put it in there. Okay, because it's too easy. So most students can do it without much practice. Okay, because the percentages are going up each year that kids can do that. The expectation is that you have to know how to do this by now.
I feel like teachers
Okay?
are just doing their job really
How do we feel? Product rule. That's the last rule for this course, and then we're just gonna wrap it up for next week. I'm gonna teach you tangents and normals, revising the purpose. Okay, so once you learn all these techniques, it's all about purpose. Know why you're doing it. Okay? All right, here we go. I'm gonna hand it out.
James, what is the quotient rule? That's just the
Oh,
same thing.
for those who want to know the question rule, you can copy it if you want. I don't think
Not
it's
on our course.
it's not on our course for year 11.
So it's just a year 12.
Yep, that's the only one extra thing you learn.
Ah.
Question rule.
Wait, so we don't have to study this?
No. Question rule is when you have u divided by v, then dy dx is equal to vu dash minus uv dash over v squared. Reason why that's an issue is a lot of kids get that mixed around because in your textbook, it's actually for product rule, it's uv dash plus vu dash. And that's why I'm teaching you the other way around, because if you know it's VU dash plus UV, then when you're doing quotient rule, it's the same idea as well. It's VU dash minus UV dash divided by V squared. That's the only difference. And the most important part is the numerator. The numerator is where most students make a mistake, because when you minus, it does matter which one is first and which one is second.
Jam out.
Okay, but addition doesn't. So that's for next year, if you want to copy that down. Here we go, I'm going to hand this one out. There's answers on the
Ready for the
back.
weekend?
Grab one,
Yeah.
practice your
Just
product
gonna
rule,
play some
please.
Please.
This one's answers for last lesson sheet. Okay, so on Wednesdays. Wednesday's worksheet.
I had it.
Answers for
My fire now.
Yeah, I better start studying.
I've got my dude. You have to. Because you know during the week.